5, 4, 3, 2, 1.
The Rocketry Show with CG and Jeem.
Welcome to another edition of The Rocketry Show with CG and Jeem. I'm CG, and Jeem is out recovering. He's been under the weather kind of off and on during the production of this episode, so you will hear him during the show. But when it came time to do our final little wrap-up and all that, he was just a little bit too under the weather to do that. So I'm in here getting things started and kicked off there. We have a great show on the way. We've got, in the next part of the show here, we've got Larry Koskie coming in. He is the prefect of the Michiana Rocketry group, and they are the club that hosted the Porta Potty launch. And Larry Koskie is also a member of the Throne Thruster team, who were the guys that assembled the Porta Potty. And this is a fascinating story. There is a lot of work that went into this Porta Potty and Porta Potty rocket launch. It wasn't like some guys with beer bottles and motors and shooting something off and saying, "Bubba, watch this." Nothing like that at all. This has been a fun interview to do, and we've got part one coming up here shortly. Also, would like to let you know that we've got the Week in Rocketry News posted as well. Check that out. We've got a lot of cool things that happened this week, including India launching a new rocket and also launching a prototype of their crew capsule. So that's cool stuff. And also in regular rocket news, Russia has a new heavy lift rocket that's successfully launched, and some cool stuff from SpaceX. Keep an eye out for the Week in Rocketry News, TWIRN. You can also see it on our website. You click on the little banner there, and it'll take you to where all of those newscasts are, and you can have fun at checking that out right there. Also, if you want to show your support for the Rocketry Show, definitely go to this link right here. It's brm.TheRocketryShow.com. It's brm.TheRocketryShow.com. What does that do? Well, that takes you over to BuyRocketMotors.com, where you can buy all the rocket motors you need from Robert over at Buy Rocket Motors. He has been teaming up with us, and we are happy that he has. And we want you to show your support for the show by using that link there. Many of you have emailed us offline and even commented on the Rocketry Forum forums that you would like for us to get some sponsorship going because you're enjoying the show. You want it to keep going. So we're working on that, and this is the first step there. And this is kind of like a pilot thing that we're doing with BuyRocketMotors.com. And depending on the success of this, we will either adjust it or whatever and offer more vendors and other folks to get involved to support the show and to keep it going. So that's cool stuff right there. And then we're going to take a quick little break here with some more information, and we're going to come back with Larry Koskie, the prefect of the Michiana Rocketry Club, and he's going to be talking about that Porta Potty rocket launch right here on TheRocketryShow.com. Don't go anywhere. If you know some friends who would get into the Rocketry Show, but they're not really all that technically inclined, and podcasts might be a little weird for them to try to figure out, well, you can let them know that we've got something really cool now. We've got a YouTube channel for The Rocketry Show. If you go on YouTube and just type on The Rocketry Show, you will find our channel, and there you'll find the episodes posted. They kind of lag about a week or so behind the main podcast, but we do post them up there, all the episodes, as well as some videos of some of my rocket launches and a few other videos for the Rocketry Show or rocketry-related things. So not only can your friends enjoy it, but there will be things there for you to enjoy too, and in the form of additional content and videos. And we'll be posting things on the YouTube channel that will cover topics that are a little bit difficult to cover when you're trying to explain in words and you really need pictures and video. Well, we'll be poking around with that stuff there. So just hop on YouTube and look for us. Just do a search for The Rocketry Show. You will find our channel right there. Welcome back to The Rocketry Show with CG and Jeem. And joining us is our very special guest here, Larry Koskie. He's the prefect for Michiana Rocketry. And he's one of the Throne Thruster guys who launched the Porta Potty rocket launch that you've seen out there in various places. Some news. He's showing us on the camera his T-shirt of that. And you may have seen this on some of the newscasts. If not, you can find it on YouTube. And there's a huge crowd there, and so it's really cool stuff. Hey, Larry, welcome to the show.
Hi, great to hear from you. It's kind of, I think the video that's out there is really amazing. And when we were looking at it, when we found it, we realized that, okay, you guys actually did have to do a lot of prep to make this happen. And what was, I guess I'll just start up. What is the purpose of launching an outhouse? What was, how did that come about? Let's start there.
Well, we have one member that he has had this idea for quite a while. In fact, he even one time mentioned he wanted to launch a Mini Cooper because I think they did something like that on Mythbusters one time. So
the British version, yeah, something like that, yeah.
Yeah, so he would like to launch something as an odd rocket of size, and just to prove that we could do it, because he thought, well, with the different members in the club, that we had the skills and ability to put something ridiculous up in the air.
and I guess this took a lot of preparation, as we mentioned, starting with small scale models. Walk us through how the process began with working your way up to the porta potty launch.
Okay, well, to start with, we were closing up the launch field for the year. Our year runs from November to April because the farmer needs to use the field during the summer, so we only get to use the winter months when there's snow, but oh well, that's what we get.
Yes.
Midwest.
So when we were putting stuff away, there was a porta-john sitting out in the field, and he said, well, if someone could get one of those, I'll donate the motors to make that thing fly. So from that, we had members thinking about, well, maybe let's build one. So within a week, one of the members had gone to a place that rents porta potties, and they donated the walls and roof to build a porta potty. So we got the plastic skin, and we were on the way.
So how long? Did you guys use any rock sim, or is it even possible to computer simulate something like that?
Yeah, that's actually where I started.
Okay.
Of course, Rock Sims doesn't do square objects. And so you just take the frontal area, which is 44 by 44, and figure out how many square inches that is, and then come up with a cylinder with the same frontal area. I forget exactly what the diameter was, but it was larger than that, probably closer to 48 or more. But anyhow, I started with a cylindrical rocket with 4 fins, and I tried to determine what size fins were going to be necessary to fly something like this.
And did you have an estimate for the weight of this already? Because I could tell that, looking at the video, you guys put in all kinds of framework into this thing and actually, built it at the framework with a skin, essentially.
Well, to start with, we really didn't know what the final weight was going to be. We really didn't think we were going to end up that heavy. We knew that the skin, the plastic, weighed 92 pounds.
Wow.
So starting with that, we then started building a frame, but we didn't really know how strong we needed to make it, so we made quite a strong frame. Easily we could support the weight of a car with it. So while we were designing and building it, we started coming up with scale models. But the scale models, we didn't know exactly how much it was going to weigh, but we knew the dimensions. So we were modeling according to those dimensions, and we come up with several models that flew, and from that we picked a certain size fin we thought was going to be adequate. Well, it was adequate according to RockSim, but everybody thought the fins I made were too large, that they should be smaller. So I said, okay, let me make one with fins that are so small that it should not be stable. And I wanted to find out what the limit was. So I made one with fins too small. It still flew. It flew perfectly. So RockSims was overestimating the size of the fins because this thing is so short, stubby, and draggy. There's so much aerodynamic drag that actually that drag adds stability.
Sort of like that pie pan effect, probably from the roof, I guess, huh?
Yeah, because for example, RockSim will not say that a pyramid can fly, where a pyramid is or a wire spool. They will not RockSim, but they do fly.
This is true.
So this is sort of along those lines. So we found that we could actually have smaller fins than we had thought. Well, according to what RockSim says, anyhow.
Okay. So you basically started off with that and then built your scale models from that based on rough estimates of what you were thinking your weight was going to be, and then actually flew those designs.
Well, weight really wasn't a factor yet because we didn't know. We thought, we figured it would probably weigh 250. That was just a rough guess.
Right.
But as we were building it, we then had a frame, and then with the weight of the skin and the weight of the frame, we were a little surprised. It's now heavier than what we thought it would be. And then from that, we had to decide on what size, quantity, number of motors, and how to arrange the motors inside this thing. So there was quite a bit of thinking and deciding before we actually had a motor mount built. We built a motor mount to hold 9 motors. We were thinking of all possibilities.
Mm-hmm.
We were, we only flew it with 7, but it is made to hold 9.
Wait, so you did the opposite of what I have been doing and learning not to do, and I always build a motor to the biggest size I think it is, and it always ends up being that I really should have made it for one size bigger.
Yeah. So we had oversized that part of the project because, well, who knew? We didn't know what we were going to fly it on because we didn't know the final weight. Other questions that we didn't know about were how we were going to launch it, where the altimeters were going to be loaded, the number and size of parachutes, the location, size of the parachute cannon. These were all things that we had to work at eventually because we first needed to know what the total weight was.
Mm-hmm.
Right.
So once we got along with the build, we could then weigh the frame, and we found out the aluminum frame weighed 195 pounds, just the aluminum.
Oh, wow.
That was a lot of aluminum.
Yes.
So from that, we estimated a total weight and picked the size of motors that we were going to need. And from that, we knew the weight of the motors.
Right.
Well, with that final weight, we could then figure out what size parachutes we needed to recover the thing. So we come up with 2 26-foot parachutes. And then, what size cannon does it take to hold 2 26-foot parachutes?
Good question.
Yeah. All right, we're going to take a quick break. I want to hear more about this cannon thing here. So we're going to take a quick break here at the Rocketry Show and come back and learn more about what it took to do to make this cannon.
Thanks for spending your time with us here at The Rocketry Show. We would love to hear from you. Send your feedback and suggestions to ideas@TheRocketryShow.com. For question and answer topics or messages to the host of the show, use mailbag@TheRocketryShow.com. Thanks again for listening to The Rocketry Show.
Welcome back to the Rocketry Show. We've got Larry Koskie here with us, a special guest. He is the prefect of the Michiana Rocketry Club over in the Michigan, Indiana area. Michiana, go figure. Anyhow, we were just talking about the cannon there, so let's get back into this. What was the engineering that went into designing this, the cannon on the porta potty rocket?
So the cannon ended up being a 10-inch diameter and 36 inches long.
Okay.
And trying to locate that inside of the porta-john was, with the frame already built, was kind of an engineering.
The engineering nightmare. Oh, I hear you. So what was the process for testing this out?
Well, we needed to test the cannon to find out how much black powder would take to push these parachutes out. And we first started with a simple formula that uses the diameter, length of tube, and amount of pressure that you want to develop. And from that, we thought it would take probably somewhere around 12 grams of black powder. Well, that blew up the cannon.
Oops.
Yeah. So then we had to build another cannon. And then we kept testing it and trying it. And we actually found that 4F black powder, it burns so fast and develops so much pressure that the pressure actually leaked past the piston and it didn't push the parachutes out very well because it built up so much pressure. It pushed it partway out. Actually, it made the cannon jump. It's kind of hard to explain. We ended up having to tie the cannon down to get the parachutes to blow out because it kept jumping with the parachutes.
Okay. Yeah, I could see that.
A little hard to explain.
Yes.
But
Well, you got a lot more weight than what we're normally used to pushing out of that cannon.
Mm-hmm.
yeah. So the testing of that actually took quite a while. We ended up finding that we had to make our own black powder because we needed a coarse powder that burned slowly. It was more like a cannon powder that was fairly large chunks. Because being chunky, it burned slower, developed less pressure, and it pushed the parachutes out more slowly and more gradually and more efficiently than something of like 4F that develops a real high pressure suddenly and blows things up instead.
You needed more of a whoosh than a boom or a bang.
Right.
In this case, you would say yes, whoosh. Very interesting.
And when you were developing with the models, what types of motors were you developing in on the test models to verify aerodynamic stability?
Well, we were trying to scale the weight of the scale models and also get a motor that produced about the same thrust and thrust to weight ratio as the full-size one. See, we were using a 1/4 scale model, which has 1/4 the width, 1/4 the length, 1/4 the height, which would actually be 1/64 of the volume. So we wanted something with 1/64 the weight, 1/64 the thrust, and impulse. So what we needed was a 600 Newton-second I motor with an average thrust of 195.
Wow.
Which is kind of a low thrust I. We were using an I-195, but it only produced, I forget, the Airtech I-195 produced, I think, like around 480 or 500 Newton seconds. So we were low on the total impulse, but we were using that motor because it had the correct average thrust, so that we weren't accelerating any faster than what we expected this full size to accelerate. In doing that, we also found that the wind was a problem. If it was too windy, this thing of being so stubby, it tended to weathercock and fly into the wind. And so,
just like a Mars lander.
yeah, we decided that probably a 12-mile-an-hour wind was probably our limit. So we didn't want to fly in a high wind condition.
What did you use as a rail guide? Was it an internal rail system, or because I wasn't able to tell from the launch videos.
That was one of the things we had to figure out is how to launch it. What we decided was to run a pipe down through the center and use the pipe as an internal launch lug. Okay. And when we put the pipe through there, we were also trying to decide where to put the altimeters because the outside surface is rather irregular and we thought there was a lot of turbulence and we didn't know how to mount the altimeters. So we decided to mount the altimeters on this pipe that runs through the center because we thought the air passing through the pipe would have less turbulence. And so we mounted the altimeters in a cavity that was ducted over to the pipe that we used for launching. So that pipe kind of answered two of our problems at one time.
Interesting.
Now, how did you duct that in the way that? Because I see what people come up with ideas of maybe I could duct air into the altimeter or have some tube as a sample. You see all kinds of warnings. You don't want to do that because you might pull a vacuum instead of what you're expecting. So
well, that was part of the concern too, because this pipe run through and it exited the bottom of the porta-john near the motors. And we were concerned that the thrust of the motors was going to create sort of a vacuum and suck air through the tube. And actually, we were afraid that we could create a vacuum that the altimeters would think that was apogee.
Right.
And fire the parachute while it was still under thrust. So actually, we modeled that on the quarter scale. I did the same thing by putting a launch tube through the center and mounting a little recording altimeter. It wasn't a deployment altimeter. It was only a recording altimeter. But I mounted it on the side of that tube, the same way we were mounting the altimeters in the full size. And I flew it, and I looked for a inverted spike or some type of spike that would show that I'm getting some false reading, and it didn't happen. So it it worked in the scale model, so we thought it would work in the full size.
Now, when you're developing the fins, I guess you had to develop some way to keep the fins nice and stable. And that was a tricky part too, between the model and when it came to the real life model.
Well, we actually had more of a problem with the scale model because I was using some lightweight 1/8-inch plywood fins, and we were getting a lot of fin flutter, and we found that the scale model, we were getting a lot of unstable flights, and we thought it was because of the fin size. But then I ended up going to carbon fiber sheet with carbon fiber tubing around the fin that made it more rigid, because the full-size Porta-John had polycarbonate fin material, but it was enclosed with a 1x2 aluminum frame all the way around the outside. And then this fin then was mounted to the aluminum frame that was inside of the Porta-John that went clear from corner to corner. So the fins were, in the full size, were actually more stable than it was in the scale model.
Okay.
Got it.
But in addition to that, we added a cable around the outside perimeter of the fins. And we used an electrical ground bar that you find, like you see in a breaker bar. We actually welded that to the tip of each fin and ran this cable around through these ground bars and tightened down the screws, and so that we went around it twice. So we had this cable run around the fins, so the fins couldn't flop or flutter without all the fins
Right.
flopping and fluttering at the same time. But, well, that didn't happen. So.
Good.
And so now you also had some tricky parts in the design when it came to center of gravity and center of pressure as you were experimenting with different ideas.
Yeah, in the scale model, well, when we were building them, we didn't know what the full-size one was going to weigh. We didn't know where it was going to balance. We didn't know where the center of gravity was. We were guessing. So we just built scale models and flew them. And from flying them, we decided, well, this is the size fin we need. We made fins for the full-size one, put it together. We then got a total weight. We come up with the motors we wanted to fly. With that, we then determined the parachutes, the cannon, and then the new total weight. We knew what motors, like I said, that we were going to use. So we knew the weight of those motors, and we could add some steel weights inside it to take the place of these motors, just so we could find out where it balanced. And then after we got it all assembled with mock-up parts for weight, we found that it was going to weigh 450 pounds. And from that, we also learned where the center of gravity was.
Now, did you balance it out like that on its side just to find its normal? Okay.
Yeah, we suspended it by a strap and kept moving it until we got it level.
Makes sense.
Okay, then we went back to the scale porta potty that we'd been flying, and we found the center pressure was way off.
Oh my!
Yeah, it was so far off. We had to add weights to the rear of the scale model, which moved the center of gravity rearward towards the back, which made it less stable. And then we found the fins were too small.
Oh no!
Yeah.
So that meant these full-size fins were also going to be too small, and we had to enlarge the fins. So we bought some 9 by 26 inch pieces of polycarbonate, 1/4 inch thick, and bolted them to the sides of the fins that were already there, so that these fins actually became 7 inches longer. The span was 7 inches greater. So that would give us enough fin. It was kind of interesting. I didn't realize we were adding dimensions. We were adding material to the fins to make them longer and also to make them wider. And in the scale model, we found that for every inch in width was equal to adding 10 inches in length. That making the fins longer really didn't help much, but making the fins wider did. And I didn't know it was a 10-to-1 ratio.
Yeah.
It's really surprised me. Here, the whole time, I thought we'd just make the fins longer.
Right.
But that was the wrong direction to go. I didn't know that.
Wow. Now you do, right?
Yeah.
Now we do too, and so do our listeners.
Yes.
So listen up, guys. If you're thinking about doing something like this, listen to what this man's saying. Larry knows what he's talking about.
I was actually designing another rocket just this week, and I was thinking of making the fins kind of minimum size because I want to put an M motor in and see how high I can fly it. And well, anyhow, like I said, I wanted to make the fins kind of as small as possible. Well, I found out it wasn't quite stable, so I thought I'd make the fins a little longer. It gave me the same reading. I went from a 4-inch root to a 6-inch root, and it didn't change. So I went from a 3.5-inch span to a 4.5-inch span, and then I got the stability I needed. Adding an inch to the width made it stable, but adding 2 inches to the length didn't change anything.
Interesting. Very interesting.
Yeah.
Yeah, I didn't know that. So getting the fins out into fresh air makes a difference.
Yeah. Well, what we're going to do is, since we're getting close to the launch here, we're going to take a break from this part of the interview, and it'll be a two-parter, folks. So when we come back, it's going to be launch day and all the final preparations leading up to launch day. And there's so much more to go on this story. It's fascinating, folks. So you definitely don't want to miss that one. And thanks for joining us on this part, Larry. And we'll see you again on the next show with part 2. Well, thanks to Larry Koskie for coming by to the show and sitting in with us and talking about the porta potty launch. He's one of the throw and thruster guys there that pulled that off. We learned a lot from listening to him talk about how to get a porta potty in the air under rocket power. And surprisingly, most of it applies to regular rocketry, too. I want to remind you that not only can you email comments to the show or questions to us here at the show, you can send your general questions and comments to mailbag at TheRocketryShow.com. You can send ideas at TheRocketryShow.com. And if you want to record a message, that's fine too. We love playing it and reacting to it. You do not need a studio to do this, folks, okay? Don't get intimidated because we're talking to you on some big microphones and all that. You could just take your iPhone or whatever with the voice memo app and just hit record and talk into the speaker on your phone if you want. And just send it off to us, and we'll be happy to play that back. We've got the technology to play whatever files your phones record in, so don't get hung up on it all. Just record it, send it off if you want to make your voice a part of the show. All right, that's it for now. We'll see you next time here at The Rocketry Show. And Gene will be back. Hopefully he's feeling better soon. And we'll be back to have our dynamic duo back together again. Whoosh and Boom, the brothers of rocketry for you here. So until next time, we'll see you later.